Bonding. In this section, we will explore the structure of materials, considering types of bonds that form between atoms is important. In chemistry, you only learn about bonds, but for material scientists, what is the importance is to understand how the bonds affect the properties of materials. My expectation is, end of this section, you will understand the different types of primary bond and non-bonding interaction present in materials, and you should be able to predict type of bonds and non-bonding interactions and the properties of materials. Electronegativity. Electronegativity is an atomic property that describes how strong and tightly an atom holds onto its electrons. An atom with higher electronegativity has a strong pull on electrons than an atom with lower electronegativity. Red represents partially negatively charged regions, and blue represent particularly positively charged regions, and white represent neutral uncharged region. Electronegativity is not possible to measure directly. To get electronegativity values, researchers have to measure something else and convert it, then relate that measurement to electronegativity. This means there are many different electronegativity scales can be used. However, the most common one is the scale developed by Linus Pauling in 1932. It is the first created the Pauling scale. He described electronegativity as the power of an atom in molecule to attract to itself. Pauling assigned hydrogen an electronegativity of 2.20. Other element values are derived from hydrogen's electronegativity value. Electronegativity is an arbitrary value. Electronegativity of an atom is a relative value of the atom's ability to attract electron density towards itself when it bonds to another atom. It is very useful in order to describe how electrons are distributed between two atoms in a chemical bond. If two atoms come together to form a bond, the atom with higher electronegativity will attract the electron away from the atom with lower electronegativity. How strong the degree to which the electrons are attracted to the electronegativity atoms depends on the difference in electronegativity. This is a periodic table showing the Pauling electronegativity of each element. From this table, we can know that electronegativity of carbon is 2.55, sodium 0.93, and others. We may also know what is the highest and lowest electronegativity. From this periodic table, fluorine from this table is the highest electronegativity. The lowest electronegativity is calcium or francium. We may also observe the trend in electronegativity which is increases has moved up to right and many more information. Let's say we have sodium and fluorine atom. If this atom form a bond, which atom will tend to attract the electron more? In this case, which is more electronegativity, sodium or fluorine? Yes, fluorine will attract the electron more because fluorine is more electronegative than sodium. What happens if a bond formed between sodium and chlorine? In this case, chlorine will attract the electron more because chlorine is more electronegativity than sodium. And what happens if bond form between carbon and chlorine? Which atom will then attract electron more? In this case, chlorine is more electronegative than carbon, so chlorine will attract the electron more. The important thing to understand here is the distribution of electrons in the sodium chlorine bond and carbon chlorine. Is it same? We can imagine they are not same because they are different in electronegativity. Different. Carbon chlorine bond more equally more but distributed but still closer to chlorine, but sodium chlorine bond electron mostly localized at chlorine atom. How about if the same element such as 2 oxygen or maybe 2 carbon atom? We can imagine the electrons distributed equally between 2 atoms.